Hello everyone, this is Pankaj and I welcome you all to New Day New Question series. So once again I have brought one more new question for you, and today's question is basically a mix of two or three concepts. So let's see what we have in this question. So as we can see, the question is saying a sea water at a frequency which is equals to 9 into 10 to the power 2 hertz has a permittivity epsilon which is equal to 18 times of epsilon naught, as well as they have given the resistivity which is 0.25 ohm meter. One more thing they are saying, imagine a parallel plate capacitor which is basically immersed in that sea water whose frequency is given and is driven by an alternating voltage source. So they have given the value of voltage which is varying voltage v naught sine 2 pi ft. Then the condition they have given that the conduction current density becomes 10 to the power x times the displacement current density after what time, that 1 upon 800 second. So value of x we want to find basically here. So let's first write the given data, and after that we will try to understand once again what basically the question is saying. Okay, so first thing which we have given is basically frequency of that sea water which is 9 into 10 to the power 2 hertz. After that they have given the permittivity of the medium which is seawater epsilon, which is 80 times of the epsilon naught. After that resistivity rho they have given, the value of resistivity is basically 0.25 ohm meter. After that they have said imagine a parallel plate capacitor. I will tell why they have used the word parallel plate capacitor is immersed in the seawater and driven by an alternating voltage. So voltage also they have given like v of t which is equals to v naught sine 2 pi ft. So voltage they have given. Then the condition they are saying, like two things they are mentioning, one conduction current density and second one is displacement current density. So we will have to understand basically what is meant by conduction current density and what is meant by displacement current density. Okay, so we have written our given data. One more thing, like time also they have given. Value of t is basically they have given t is equals to 1 by 800 second. So these are the certain things which are mentioned in this question. Okay, now so as I was saying, like two things they have mentioned in this question. One thing is basically your conduction current density and other thing is basically your displacement current density. So in short I will tell you like what is meant by conduction current density along with the formula, and second thing is basically we have displacement current density. So remember everyone, like what is meant by conduction current. So basically conduction current is that current which is because of the actual flow of electron, whereas the displacement current is the current which produces because of the changing electric field. So whenever we try to write the conduction current density, the symbol which we use for conduction current density is JC, and the symbol which we use for displacement current density is basically your JD. Now what is the formula we have for the conduction current density? So the formula which we have for the conduction current density is basically it is E into sigma. Sigma stands for your conductivity, but in the question they have given the resistivity which is 1 upon the conductivity. So I am going to use E by rho. Second, displacement current density formula. So the formula which we have for displacement current density is epsilon dE by dt. As I have already told you, this displacement current density is because of the change in the electric field. Okay, Now let's try to find the answers of our question. So first thing which I'm going to find is the current density, conduction current density. Second thing, I will basically find the displacement current density. Then I will take the ratio and then I will match with the given condition which we have given in the question. Okay, let's try to find the value of JC then. So value of JC is basically E upon rho. Now one more thing which we are going to use here, which we already know, is our voltage is directly proportional to electric field. So instead of E, just like we have given the equation of voltage V of t, which is equals to V naught sine 2 pi ft, I can form one equation for electric field also, and that equation will become changing electric field E of t is equals to E naught sine 2 pi ft. Okay, now let's try to find the values of our question. So first thing is conduction current density, which is E upon rho. Value of E is E naught sine of 2 pi f into t. Okay, divided by what we have, basically rho, which is our resistivity, equation number 1. Similarly, next thing we will find JD, which is displacement current density, epsilon dE by dt. So epsilon is permittivity of the medium. Now differentiation of electric field. So as we know that E naught is constant outside, differentiation of basically your sine 2 pi ft will be cos 2 pi ft according to chain rule. Further differentiation of 2 pi ft will be 2 pi into f. This is the equation number 2. Now let's take the ratio of equation 1 and equation 2. So from 1 and 2. So from 1 and 2, it means we are going to take the ratio of JC by JD. So value of JC we have epsilon naught sine 2 pi ft divided by rho we have. Similarly, value of JD, how much we have, epsilon into E naught into cos 2 pi ft into 2 pi f. This is the value we have basically for the JD, which we have put here. Now this E naught and E naught will get cancel out. Second thing, sine by cos will become basically your tan. So equation will become tan 2 pi f t upon rho into epsilon into 2 pi f. This is basically JC upon JD. Right now I am giving this equation as a name, equation number 3, because I will need the value of 2 pi ft. So first I will find the value of 2 pi ft. Okay, so let's try to find the value of 2 pi f and 2 pi ft. So 2 pi f into t. So 2 pi as it is. Frequency, how much they have given? Value of frequency is 9 into 10 to the power 2 hertz. 9 into 10 to the power 2. Time, how much they have given? That is 1 upon 800 second. 10 to the power 2, and these 2 zeros will get cancelled out. 2, this 8 will be basically 4 times, so it will be 9 pi upon 4. Now this 9 pi upon 4 can be written in the form 2 pi plus pi by 4, because after simplification you will have 4 2s are 8, 8 pi plus pi, 9 pi by 4. Now why I am writing this term? Because what I need 10 2 pi ft, and the value of this 10 2 pi ft, how much we got? We got this 10 2 pi ft as, let me write it in the next row so that we can write it properly. So what is the value we have? 10 2 pi ft will be equals to 10 2 pi plus pi by 4. Now we know that 10 2 pi plus theta is basically your tan theta, so it will become 10 pi by 4. 10 pi by 4 means basically 1, so we can replace tan 2 pi ft by simply 1. Okay, now one more thing which we will need is value of 2 pi. So this is the one value, this is the another value, and at last one more thing which I will need is basically 2 pi f. Or let's do the, like, we can put that 2 pi f directly in the equation. So from equation 3, from equation number 3, we will have JC upon JD is equals to, value of JC is 10 2 pi ft is basically 1, so I will replace it by simply 1. Now what is the value of rho we have? Value of rho is 0.25 they have given. Value of epsilon, how much we have? It is 80 into epsilon naught they have given. 2 pi f we want to find, 2 pi as it is. And value of frequency, how much we have? Value of frequency is basically which we have put earlier, which is 9 into 10 to the power 2. 9 into 10 to the power 2. These are basically values which we are going to need. Now let's try to simplify them. Okay, now 0.25 I'm going to put, but after some time. Now 80 I'm keeping as it is. Now epsilon naught we need to put. So we know that basically in the question also they have given like 1 upon 4 pi epsilon naught. This 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. So from here we can find the value of epsilon naught, which is nothing but 1 upon 4 pi into 9 into 10 to the power 9. Okay, so we can replace this epsilon naught by 1 upon 4 pi into 9 into 10 to the power 9, and we have put the value of epsilon naught. After that 2 pi into 9 into 10 to the power 2. This 9 and 9 will get cancelled out, pi and pi will get cancelled out. After this we have basically 10 to the power 3, which will basically become 10 to the power 6. After cutting it will become 10 to the power 6, and 0.25 is basically your, what we can say, 1 by 4. Now what will happen? This 1 by 4 and 4, it will become basically your 16, and we know that 8 2s are 16, and again this 2 and 2 will get cancelled out. So ultimately what we got GC, that is conduction current density, by JD, which is displacement current density, is 10 to the power 6. So as per the question what they have said that conduction current density becomes, that is equal to, we want to find the value of JD. So value of JD will be 10 to the power minus 6 times the conduction current density. So if we compare it with the given question, we can say that like 10 to the power minus x, 10 to the power x they have said, like the conduction current density becomes 10 to the power x times the displacement current density. So in terms of displacement current density, it means no need to like take the basically ratio, we can simply multiply it, and what we will get, like JC is equals to 10 to the power 6 times of JD. So as per our question, the value of x should be equals to 6. So value of x, how much we got? 6. So this was the solution for the question which we have taken today. I hope you understand the solution. Thank you very much.